Using DeepChain, we can perform in silico site-directed mutagenesis on a protein complex where we select the position we want to mutate and the amino acid we want to replace. This lets us see how the modification will affect our complex on several parameters, including stability and binding. Our example looks at the complex formed by prolactin and its receptor. To input our PDB structure, click on Data Source. In our case, we will be using the PDB ID 3MZG. Our structure is displayed in 3 dimensions. The orange color represents the receptor and the green the prolactin. In the upper tab, our sequence is displayed with both chains. In the receptor sequence, we will look for the position 188, which contains histidine, and select it. The letter will be highlighted as well as the position in the structure window. At the same time, in the site-directed mutagenesis window will appear H188_. What we will do is replace it with R, symbol of the arginine amino acid, and then click Run Experiment. A window pops up allowing us to select the app and the scorer that we will use for the experiment. We will select the log likelihood app in both and click on Run. As we can see, our experiment is launched and it will take a few hours to process. Once our experiment succeeds, we can explore the results. To do so, we click on the experiment. Within the results, we see different sections. We have options, a table, and a graph. In the Options section, we select what parameters we want in the results table and in the graph. We'll select stability and binding as our parameters. The results are presented as free energies for both binding and stability. For a better binding or a higher stability, we're looking for the lowest value. In the graph, we will see that the native structure represented with the pink dot has a better binding and a higher stability as expected. We can also compare result values in the table. The experiment shows us that by substituting the histidine in position 188 of the receptor with arginine, we reduce the binding between prolactin and its receptor. What we have done in just a few clicks replicates what was done experimentally in a research paper highlighting how a single mutation on a prolactin receptor can lead to a disease called hyperprolactinemia, which causes infertility. After seeing how easy it is to run a site-directed mutagenesis experiment in silico using DeepChain and the reliable results it provides, just think of all the possibilities this powerful, time and resource-saving tool offers. To learn more, sign up now at deepchain.bio. Thank you for listening. Thank you for your time.